All right, let's go over the radial arm drill press worksheet here. So the first thing is we're going to calculate the chord length for the assigned bolt circle diameter. Now what I'm going to do is I'm going to bring up another image that's similar to this print down here. It has the same information, but I'm going to work through all of these steps on my print that's a bigger circle with different sizes than you'll be using. So here's the print that I'm going to be working off of to solve the steps that we were just looking at. First thing is, this is a much bigger bolt circle that I'm going to solve with you today. It's a 30-inch diameter BC. BC stands for bolt circle. I'm going to have some rather large 3-inch 12 threads per inch unified national tapped holes, and then a big 3-inch ream hole in the center, and 2 3/4 inch ream hole on the outside circle. The first step with our worksheet here is to calculate the chord length for the assigned bolt circle diameter that you have. Now, the chord length is what I have dimensioned right here, and I went ahead and did this so that way everyone could see and understand that it's a straight line distance from the center of this hole to the center of this hole, or the center of this hole to the center of this hole, or you get the point. So it's a straight line measurement. Now what that chord length will do for us is, if I have a circle and I know the chord length, I can set a pair of dividers and I can scratch a line and then pivot and scratch a line and then pivot and scratch a line, and I can work my way around this bolt circle and I can evenly divide it. And if I have the right chord length, then I will have evenly spaced holes that I can later drill and ream or drill and tap my holes. All right, so 30-inch bolt circle is our diameter. What I'm going to need to solve this is our machinist ready reference. Take a quick peek to the index. We're looking for chord length. So I'm looking here. I see chord length for spacings of circles, page 19. All right, so on page 19 here, it says angle at center and length of chord for spacing off the circumference of a circle. Over here it says spaces on the circle, and it starts at 3 and then it works its way up to 40. Now the reason it starts at 3 is if you have 2, then you know that your 2 holes would be on opposite sides of the circle. So if you had 3 evenly, if you divided a circle into 3 even sections, then there would be the angle at the center, there would be 120 degrees in between each section. Or if you had a 4 bolt hole circle, you divide 360 divided by 4, you get 90 degrees in between each bolt circle. And I think you get the point there. Now to the right of that, there's another column here that says length of chord. Now, the length of chord, so let's say for this three circle bolt pattern, the length of chord would be 0.866025, but there's a little asterisk next to the length here. And what that says is down here at the bottom of the page, is it says this table is calculated for circles having a diameter equal to 1 inch. For other circles, multiply the length given by the circle's diameter. Okay, so we have 7 spacings on our circle, so I need to look right here at the spaces on the circle column at 7. I scan across and I see 0.433883. So if I do 0.433883 times my 30 inches, That's going to give me a chord length of 13.016. And right here in my CAD program, when I drew this up, it rounded up from this number here calculated up to 13.017, which if I'm using hand layout tools, that's that little error, that rounding error, I'm not concerned because I'm not that accurate with my hand layout tools. I wish I was, but we're just not going to get to that level. So I've calculated that chord length. So what I'd do is I'd write it down on my sheet of paper here. Now the material, it's already been provided. The first thing you're going to be doing with the material is you're going to be cleaning off the shipping grease that's on the plate, and then you're going to be using a file to deburr the plate. I pre-cut these plates for the students just because the material is size and the weight. It's not very fun to handle, but I leave the burrs on the material because it's important for you to begin to learn how to use a file and to understand that you're going to be filing off burrs constantly in the machine shop. Pretty much every time you perform a cut, there's going to be a burr that needs to be filed away. Next step here is layout per sketch. Now I'm going to do a large layout of a 30-inch bolt circle on the chalkboard, and then I'm going to divide that circle into 7 even spaces, just like we have here. All right, let's pretend this piece of chalkboard is your part, and you've got your part, it's been deburred, you put the bluing on, and you're ready to start to do all your layout lines. The first thing you're going to do, of course, with your plate is you're going to take a 12-inch ruler and go from corner to corner across the part, and you're going to scribe a line, and then go from the opposite corner to corner and scribe a line, and where those lines intersect is going to be the average center of your plate. Now after you do that, you're going to take a pair of dividers and set it to the radius of your bolt circle diameter that I've given you. In this example here, remember, we're sticking with a 30-inch diameter circle. So to find the radius, I would need to divide the 30-inch diameter by 2, which would give me 15 inches. I want to go ahead and open my dividers here to 15 inches. And then I'm going to scribe my circle. Now, your dividers that you're going to be using, we can achieve a rather high level of accuracy with time and practice. This chalk, it's not very accurate, but it'll definitely work for what we're trying to illustrate here. So if you've scribed your circle and you measure across with your ruler and you're very, very happy with the diameter, I want you to take the set of dividers that you just used and put them to the side, and we're going to pick up another pair of dividers to scribe our chord lengths. The reason we're going to do that is, it's often the case that when you're going around and you're trying to make your marks for your chord length, things don't always turn out perfect the first time. In fact, most of the time it takes the students at least 2 tries and sometimes several more. But it's okay, because that's how we learn these things. So take your diameter that's set, put it to the side, so if you do make a mistake, you can put bluing on the part again, and then you can come back and scribe that line very quickly. I don't have that luxury. I only have one set of dividers, so I can't make a mistake. Remember the chord length that we just calculated? It was 13.017. Close, the best I can do with this equipment is I know that that's 13 inches. So now I've set a set of dividers to my chord length of 13 inches, and I want to start to walk around the circle. Now when I'm going around the circle, I'm going to start at the 6 o'clock position, And on your plate, the way that I would find the 6 o'clock position would be I would take my 12-inch ruler, I would take the square head, and I would put it against a factory edge of the plate that you've been provided, not the saw cut edge. The factory edges are more likely to be straight than the saw cut edges from our shop equipment. So I would put my divider head against the edge of the factory edge of the plate, and then I would extend the ruler up until it intersected the center of my part. And then I could lightly scribe a line going down. So then I would have located the 6 o'clock position. Now I'll take my divider, as accurate as I can, I'll place it at the intersection of the lines, and I'll scribe a little arc, and then I'll go to the opposite side, and I'll scribe an arc. Now where the bolt circle and my arc, the intersection where they met, I'll put the dividers on there, and I'll scribe. Move to the next location, same thing. Now, one trick that I'm going to do is instead of continuing to go around the circle like this, I am going from each end to meet in the middle, and what I'm doing is I'm dividing my air amongst both sides. And the air that I'm talking about is if my dividers are a little bit too close together or a little bit too open, if I make the whole trip around the circle, the last gap or distance error is going to be much larger than if I divide it. We're going to do the best we can, but let's be honest and realistic. We're going to have a little bit of error when we're using these kind of tools. Holy shnikes. Okay, so that is a very, very, very large error. All right, so what we can see here is that my dividers were open too far. And since I went from both ends, I had spread that error out, but you can see how the lines are not meeting down here. They're arcing at the top because they've overshot each other, and that's on both sides of the circle. With chalk and these wooden dividers, this is about as good as you're going to be getting. With your actual tools, your divider and your plate, you should be able to get to where you can barely perceive any error, if there is any at all. And the more accurate we are at the beginning, the better our finished product is going to be. So take your time. If this was my actual workpiece and I had a miss where I just thought, hey, I can do better than that, what I would do is I would throw layout dye on my circle again, wait for it to dry. I would pick up my other set of dividers that I did not change, so I can quickly re-scribe my circle and then make my adjustment to my chord length dividers, and then do the process one more time. Continue to do that until you either exhausted your capabilities or you end up with a good part. Next step will be to prick punch and then center punch our locations before we move to the radial drill press. All right, so here's my part. As you can tell, it's covered in packing oil, and there's some pretty dangerous burrs that are hanging off the corners that the saw produced. The first thing I want to do is I can actually just lightly damp a corner of a paper towel in the solvent tank, or I can take the entire part to the solvent tank, which actually works better, but for filming, I'm doing it this way. And I want to wipe off all the oily surfaces, and I'm being very, very mindful of the burrs, because the last thing I want to do is cut myself when I'm cleaning a piece of material in preparation to remove the very burrs that just cut me. So handle with care. And always remember that these sharp edges can easily cut through gloves. And I don't care if it's a leather glove, the sharp corners, the burrs, they can go right through, especially if it's a big burr. And certain materials are more hazardous than others. You see it just tore the towel there, because I have all kinds of sharp little corners hanging off this plate. So taking the part to the solvent tank is by far better. Now, next thing I want to do is talk about filing. Now, whenever you're working, I want you to have a file nearby and a file card. These are essential tools for a machinist. When I use a file, what I'm going to be doing is gently stroking the file across the surface that has the burr. Now you can see that burr, it's pretty significant. So let's actually look at that one first. What I want to do is remove the sharp edge. I'm not trying to add a 16th by 45 bevel on this plate. I just want to remove the hazardous edges. So this part here, what I would do is I would start with a file angle that's almost parallel to the part surface here, and I would take my file cuts at that shallow angle, and you'll feel the file when it's actually cutting the metal. Now I've taken a few passes, and actually one little burr right here, that little burr just cut it free and broke free. So after a few strokes at that angle, I will go to about a 45, and I'll do another few passes with the file. And then now I'll have the file where it's getting close to being parallel with this surface. And I can take a few strokes of the file. And you will see that the burrs get cut away. And with the towel, I can wipe away all the material. And notice when I check, I'm checking perpendicular to the burr that was there. Because if I take my finger and run it that way, if there's a burr, I'll know, because there will be blood coming out of my finger. So I don't feel anything on that edge. Now I need to do all the other surfaces that have burrs. One thing that you should do is probably go ahead and put this in a vise. Actually, I'm going to go ahead and show you what that would look like. So a vise is going to hold the part for you. It's going to be a lot better. But sometimes we defer parts that we're just holding on to. Now the nice thing about a vise is I can support the tip and then also have my hand on the handle. And I'll do the same thing where my file is almost parallel to the surface. I can make a few passes, I can change the angle, make a few passes, then change the angle, make a few passes. At this point, the file teeth have formed enough chips that the flutes are starting to get loaded. So that's why I have my file card, because a few quick strokes of the file card, now my cutting edges are clean and they're ready to remove more material. We want to have sharp tools all the time. So go ahead, use a bench vise if there's one at your disposal. If not, sometimes you got to file while you're holding the part. Just be very careful. And then something I need to mention is in the LCC machine shop, our Vise Jaws have been ground flat. Most Vise Jaws may have some sort of serrations on them, and that's hardened steel. So be very, very aware of sticking parts in vices and clamping down, because if these jaws hadn't been smooth, I would have checker lines, marks on the surface of my part, which for a lot of parts, that can mean a scrap part. So now my surfaces are clean, there's no burrs, and my layout die, it's gonna have the highest contrast because I'm not trying to put it on over a bunch of oil that's left on the surface. All right. So now my layout die has dried. I've went and got a 12-inch ruler and a scribe. Now this is a scribe, not a center punch, not a prick punch. Don't strike this end with a hammer. It's for scribing lines. What I want to do to find the averaged center of this part is I want to position my ruler to where it's spanning from corner to corner. Then I want to scribe a line across the center section. Then now I'll move to the other corners. All right. So that X is our averaged center of the part. Put the tips back on your scribes when you're done using them, so that way they don't get you, and also if you drop it, they don't become damaged. Now this is a prick punch, and beside it now I'm holding a center punch. So you can see the center punch has a broader angle, and the prick punch is a more precise tool. When I'm using the prick punch for my first strike, I'm just gonna very lightly, almost the weight of the hammer is the only force I'm gonna use while I make my first mark. And the reason I do that is because if I'm slightly off location, let's say to the right side of my intersection, I can actually angle my prick punch in a slight corrective manner like this, and I can sort of skid my first mark over to the true position. You always want to get as close as you can, but I'm gonna actually intentionally miss to this side. Then I'm gonna show you how I can kind of skid the center punch mark back to the true intersection. Another thing worth mentioning is use of a magnifying glass will help prevent you from making an error. So if I really get down and I'm looking at the tip and I'm using my magnifying glass, as long as I'm careful when I do my center punch strike, I'm probably not going to have an error. So this is a cheapie magnifying glass. You know, it was a free giveaway. A quality one might be something that would benefit you if you're going to be doing a lot of layout work, or actually just in general. It's good to have a magnifying glass because you can inspect all your cutting tools and other any fine detail work that you're doing. But like I said, I'm going to miss on purpose. Okay, I didn't miss as much as I thought I would, but I am definitely favoring my finger side of the intersection of the lines. So what I can do is I can slightly angle my prick punch and then sort of skid it to be more centered. It's always best to just do it right. I would never encourage you to intentionally miss. But now I have improved its location. This first centered hole, we can go ahead and we can do a heavy center punch after we prick punch, because it's not going to go anywhere. But when we scribe our lines around this part, we're most definitely not going to do our chord length and do one intersection location and then center punch that, because if there's an error, we can't change it. The indentation is going to be stuck in the plate, and then you basically have to turn the plate over, and you can only do that one time. So before I do my center punch mark, I have a big chunk of steel plate, and I'm going to set the part on that, and that's going to make the force from my hammer put a deeper indent into the part. And I'm going to have to move slightly off out of frame, or I'm going to hit my camera. All right. So now I'm very happy with that center punch mark. One thing worth noting is when you're swinging a hammer at an object, what you do is you never take your eye off the surface that you're going to strike. If you start looking at the plate over here or your hand, that's when you miss with a hammer. Keep your eye on the target and you probably will not miss. Now what I want to do is I'm just going to make up a bolt circle diameter, because obviously I can't make a 30-inch circle on this little plate. So let's say that the size that I was provided was 4 7/16. The easiest way to divide a fraction into to divide it in half is to convert it into a decimal. So what I want to do to convert a fraction into a decimal is, I know that it's 4 inches, so I know I'm going to be 4 point. And then I'll take the 7/16 and I'll just divide that, or run it through a calculator just as it's showing. So I'll do 7 divided by my 16, and that's 0.4375. So I know that 4 7/16 equals 4.4375. Now I need to divide that by 2 in order to find out my radius that I'm going to set my center to center distance with on my dividers here. Equals 2.21875. Now, that's the distance that my divider is going to be open to. So what we want to do now is figure out what the fractional size that this 2.218 is equal to. Well, I know that if I was at 7/16 and I divided it by 2, that I would be at 7/32. I can check it. 7 divided by 32 equals my 0.218. Or if that was confusing, I can just walk over and I can look at a wall chart that I have, or I can open up my ready reference and I can find a fraction to conversion, but 7/32. So when I'm looking at my ruler here, I'm going to be using the side that has the 30 seconds markings. So I know each marking on this surface is a 30-second, and I know that I'm going to be going for 7 30-seconds. So you see how there's the 8 right there. Then I'm going to go one mark to the left of that, and that's my 7 30-seconds. But I also need to account for 2 inches. So what I would recommend you do is, first off, make sure you're using quality tools. This is SPI brand. It's probably the cheapest but still acceptable measuring tools that you're going to find. And the marks are actually indented into the ruler. They're not just printed on the surface, they are engraved. So engraved, it costs a little bit more, but it's worth it. One great thing you can do with an engraved in marking is I can set my divider tip into one of those grooves at, let's say, the 1 inch mark, and then I can go 1 2 inches, so I'm at a 2 inch radius now, and then I can continue to open my dividers until it looks like I'm right at the 7 30-second mark. So now I think I have these set to scribe a circle and end up with a 4 7/16 diameter. Now what I like to do is set my divider into the center point. I like to scribe a section of the arc, and then I like to go to the opposite side and scribe a section of the arc. Because with those 2 sections, I can take my ruler and I can measure across, and I can get a reading and determine if I like my diameter. And I don't like this diameter. I'm about, well, actually, let's see here. I'm about a 64th small on my diameter. And I'm going to fix it. Because if my circle's off, then even if my chord length setting is correct, I'm going to get an error because my circle is not accurate. I only want to adjust half of my error. So that means I'm just going to, I'll position my divider back in here so I can see my previous line. And I'm going to barely open them to about the error that I think I just witnessed. Now I can scribe, and I can scribe, and then of course I can check again. And to get a better view, I'm gonna stand the ruler on edge, and I'm gonna squat down and get a good vantage point, because looking down like this, there's a slight amount of parallax error due to the thickness of the ruler. So the line is below the surface here that has the scribe mark. So there can be a shift depending on the angle that you're looking at. So we want to line our head up to the part in the ruler. And I'm going to go ahead, actually I'm going to burn an inch. I'm going to start at the inch mark, so I can line that up better than the end of the ruler. Okay, so that's looking pretty good. Next thing I need to do then is cover up my mistake. And that's kind of like what we talked about. And then I'll re-scribe the line. I'm gonna go ahead and just do everything. Then I'll go ahead and I'll re-scribe the full circle so that way it's a uniform. So I've got my circle scribed on here. I'm happy with the diameter, so I'm taking my dividers, I'm putting them off to the side. Now, I want to locate my 6 o'clock position hole, and like I said before, I want to go off a factory edge, not a saw cut surface. I'm just going to hold the square head against the surface and then intersect the hole. Now, that's going to be my 6 o'clock position. When I put this in the vise at the machine, I'm going to orientate this hole position to be on my side of the vise because that's how I'm going to be holding my print. I want my print and my part to agree with each other if possible. So to figure out my chord length for this circle, I need to divide my 4.4375 bolt circle diameter. I need to multiply. So to figure out my chord length for this 4 7/16 diameter, I'm going to take 4.4375, multiply that by the 0.433883 that was in our book, and that'll give me the chord length of 1.925. Now, 59/64 equals 0.921, and that's pretty close. So that's the marking that I'm going to line my my divider up to on my ruler. So I'll be using the 64th scale on this one, and the 64th scale is very hard to see, so this might be a good time to be using the magnifying glass. So I'm going to start in the 1 inch mark. Now I travel the inch because I'm going to 2 inches. And there's 56/64. Trying to get this on camera is hard. So 57, 58. This next one's 59. It's very fussy. I'm going to set my divider tip at my 6 o'clock position. Describe a little bit of an arc. Swing to the opposite side. Describe a little bit of an arc. There's no rule that says you can't move the plate to give yourself the best advantage you can. Do whatever it takes to be accurate. Okay. So I'm pretty happy with those lines. I did have a small gap where my dividers were just ever so close, but I'm okay with it. If I saw a gap that was twice the error that I'm witnessing here, I would re-blue this surface, scribe the diameter again with my dividers I never changed, and then come back around with a small adjustment and then see how that ended up. But I'm going to go ahead and I'm going to prick punch these locations and then center punch the locations because it's time to go to the drill press. Now when you're doing the heavy center punch strikes like that, what you don't want to do is start hammering on the end of your center punch like it's a nail, because your tip can jump out of the location and then you'll end up with a severely off location heavy center punch mark. Pretty much at that point you have to flip the part over and then start again, because the drill bit in a drill press is going to follow the center punch mark. Milling machine, there are certain things we could do to correct the location, but in a drill press, we're pretty much committed to where we make our marks.